Hey everyone, welcome to today's Explainer. You know that incredible feeling when you first start a Laravel project? You just type PHP artisan make controller, and boom, you get right to work. It's so fast, and honestly, it's perfect for a simple to-do app. But what happens when your application actually starts to grow? Today, I'm going to be your enthusiastic guide through the architecture of truly scalable Laravel folder structures. We're going to look at exactly why those default out-of-the-box Laravel folders completely break down as your apps move past those basic tutorials, and more importantly, how we can fix them to build rock-solid, production-ready systems.
Okay, let's dive into this. Think of this as a quick house tour. We're going to restructure 5 core areas today. We'll tackle the flat folder problem, redefine the controller's true job, settle the debate of actions versus services, look at structuring data using DTOs and enums, and finally, we'll cover how to avoid some of the most common architecture mistakes.
So, let's kick things off with our very first hurdle, the flat folder problem. Picture this, 50. In a real breathing production application, you might easily wind up with 50+ controllers, maybe 30 different services, over 20 jobs, and let's throw in 15 model traits just for fun. If every single one of those files is just crammed into a single flat directory, you are going to spend way more time just scrolling and searching for files than actually writing code. It's incredibly painful to manage.
And look, it's not just about the headache of searching for files. When everything lives in the exact same place, it is just way too tempting to dump all your new logic into whatever class you currently have open. It's a trap. This architectural paradigm shift we're talking about today prevents that code bloat. Grouping your files by domain actually forces good habits because it makes the right place for new code completely obvious. Your controllers finally stop getting so fat, your models stay clean of all that random logic, and by isolating your dependencies, your code actually becomes testable again.
Moving right along to part 2, the controller's true job. It's time to put these controllers on a diet.
Here's the hard truth. Controllers should only handle HTTP. That is it, nothing more. A controller's lifecycle should be strictly limited to these 5 exact steps. First, receive the request. Second, validate the data. Third, authorize the user. Fourth, delegate the actual heavy lifting to a service or an action. And fifth, return a response. There should be absolutely no business logic, no loops, and definitely no database queries sitting in your controllers. If they're doing anything more than just managing HTTP traffic, they've completely outgrown their single responsibility. So that raises the question, if we're stripping all of this business logic out of our controllers, where does it all go?
Which brings us perfectly to Section 3, Actions versus Services, and how we extract that logic. Let's contrast these two concepts because they get confused all the time. First up, we have actions. An action is a single-purpose class that performs one specific operation. It's executed exactly once to complete one atomic task. Now, on the flip side, we have services. A service is a collaborator that you inject into your code and probably call multiple times. It contains stateless domain logic for things that span multiple models. Think querying, computing, coordinating, or talking to external APIs. Keeping these two definitions strictly separated is absolutely crucial for a scalable architecture.
But wait, to prevent these fancy new actions and services directories from just becoming their own flat, overwhelming lists, we need a rule. So here is your golden rule of thumb. Group them into subdirectories by domain whenever you have more than 3 related files. For example, the second you have 3 or 4 files all relating to users, just create a services/user/or actions/user/directory. Keep it clean. Now that we've separated our logic into these distinct layers, how on earth do we safely pass data between them?
That leads us into Section 4, structuring data using DTOs and enums.
Our first modern tool is the Data Transfer Object, or DTO. Think of DTOs as immutable, strictly typed containers. They completely replace that awful old habit of passing around raw arrays. I mean, instead of tossing a giant array around and just kind of crossing your fingers, hoping that a first_name key actually exists, you pass a typed object. And this brilliantly illustrates why modern PHP is so great. By utilizing the read-only modifier, these properties become completely unmodifiable after you construct them. That is absolutely perfect for data you want to pass around safely without any risk of accidental mutation.
Right alongside those DTOs, we have enums. Enums are typed constants that represent a fixed set of values. They entirely eliminate the danger of using random magic strings scattered all over your codebase. You know what I mean. Manually typing out status equals pending in 20 different files. No way. By using an enum, you instantly get IDE autocompletion, you get static analysis, and you can even attach specific behaviors directly to those values. It's a real game changer.
And finally, Section 5, Avoiding Common Architecture Mistakes. Let's talk about the pitfalls. As you're structuring your app, I want you to think of the app support/directory as a private little package that lives inside your codebase. This is literally the most commonly skipped folder by developers, yet it is so crucial for shared utilities and infrastructure. It's the perfect home for code that everything else depends on, but that doesn't really belong to one specific domain, things like reusable traits. Keeping these shared utilities separated here is exactly how you prevent those nasty circular dependencies.
Let's just quickly run through some specific messy mistakes we see all the time. Mistake 1, relying on flat folders with 40 files instead of just making subdirectories. Mistake 2, skipping that app/support folder we just talked about and copy-pasting the exact same trait into 3 different models. You already know how that story ends. You fix a bug in one file and completely forget about the other 2. Mistake 3, using apps/helpers as a dumping ground. Seriously guys, a helpers.php file with 50 random functions is a terrifying God file. Don't do it. Every function really should be a method on a dedicated class. And mistake 4, not grouping your services by domain, leaving you with stray user actions just floating around aimlessly in your main directory.
So, as you start refactoring all of this, I have to ask you directly, do you ever look at a piece of code and feel totally unsure where it belongs in this new architecture? Honestly, it happens to the best of us. Let's look at a definitive, easy-to-use checklist to solve this once and for all.
So the crucial point is this mental heuristic checklist. Commit this to memory. Whenever you write a new class, just ask yourself, is this HTTP specific? If yes, chuck it in the HTTP/directory. Is it just one atomic single action task? Put in action/. Does it span multiple models or need to coordinate complex logic? That belongs in services/. Or is it a shared utility or trait that's used across multiple domains? That goes straight to support/.
Now, right before we wrap up, I need to give you a very important grounding tip. Please, heed this warning. Don't over-engineer your folder structure before you've even built your first feature. Start with a simple layout and just move things around as they naturally grow. Premature domain splitting usually just leads to a bunch of sad, empty folders and some incredibly awkward imports. Let the structure force good habits for sure, but please don't force the structure before the code actually exists.
Well, we've covered a massive paradigm shift today, from slimming down those bloated controllers all the way to safely passing our data around with DTOs and enums. So I want to leave you with this final provocative question. Are your fat controllers finally ready for a diet, or is your application just going to completely break down at Route 21? Take a hard look at your current codebase today and see where you can start moving your logic into its obvious rightful place. Thanks so much for joining me on this explainer, and happy refactoring.